everybody, I want to give you just a little bit of an introduction to the idea of vectors, which is going to be the last topic that we're going to discuss in this particular school year. This chapter at the end is one, sometimes we get all the way through it, sometimes we just get a little introduction. In our case, obviously, we only have 3 school days left, so it's going to be a little introduction. I think it's a neat application of a lot of the things that we've been working with, and especially some of the right triangle things, some of the trigonometry ideas. We'll kind of see these things come together in this topic, and this topic is a topic that can be kind of expanded into some other areas, especially when you take pre-cal. So anyway, a couple of days we'll do a little bit of work with this. So we're going to start out with the basic concept. We're working with vectors, and the question is, what exactly is a vector? It's very simple. A vector is a mathematical quantity that has a size and it has a direction. Okay, those two things, a size and a direction. And probably from the standpoint that most of you would be coming from, the easiest way to explain the difference would be looking at the idea of speed versus the idea of velocity. Okay, a lot of times we use those two words interchangeably, but they're not actually the same thing. Okay, speed does not have any direction implied. Okay, if I drive a car north at 60 miles per hour, we just say the speed is 60 miles per hour. If I drive a car to the south at 60 miles per hour, we still just say the car is going 60 miles per hour. Velocity, you may be aware, velocity actually has a sign. Okay, a velocity can be positive or negative. Maybe going positive 60 miles per hour, maybe that means I'm going north. Maybe negative 60 miles per hour means I'm going south. All right, but you can also drive at different directions, you know, not just forward and backwards. Maybe you can go off at an angle or something like that as well. And so that's an important idea, the idea that there's a directional aspect to a vector in addition to just having a value. Okay, by the way, if you do just have a value, it's called a scalar. Okay, speed is a scalar, it's just 60 miles per hour, that's it. Velocity is a vector, negative 60 miles per hour, positive 60 miles per hour, 60 miles per hour at a 20-degree angle, that sort of thing, okay? Now, how are vectors shown? A vector is going to be depicted as, you might have heard the term maybe in previous math courses, it's called a directed line segment, okay? It's going to have a length, it's going to have a direction. Okay, and I can pick that vector up and I can move it to different places. The length and the direction won't change. All right, I'm going to give you just a real quick example of a vector problem that I usually introduce to my classes. Won't do quite the setup that I have done in previous years, but just to give you a very simple one that's within range of basic understanding. So a couple of years ago, I went to the airport. I was taking a flight, and if you've gone on a plane, you know that airport terminals are very long, okay? And they're so long that at a lot of airport terminals, they have these flat walkways that move. And so you can be carrying on your luggage and all that. You can stand on it, and it'll just kind of scoot you along. So this is America, okay? People are lazy. People like to just step onto the thing and have it move them. On the other hand, if you have a lot of downtime at the airport, and some of you may have done this as well, you might do things like, oh, I'm going to walk really fast in the same direction as the moving walkway, and I'm going to feel like I'm going really fast and I'm blowing by other people. Or if you're really, really bored, you might even say, you know what, I'm going to try to run opposite the length of the walkway, maybe if there's nobody on it, and I'm going to see if I can get down to the other end of the walkway, okay? And this is a great vector problem. So let's imagine that we have a moving walkway that is moving at 3 meters per second to the right, all right? Okay, so this vector has a length, it has a size of 3 meters per second. That term, by the way, is called the magnitude, okay? The size is referred to as the magnitude. So the walkway is moving this direction, okay? Let's say that you get on it and you are moving at 5 meters per second. You're gonna try to walk pretty quickly, okay? So now this thing is already moving you at 3 meters per second if you just stood still. Okay, you get on and you are moving at 5 meters per second to the right. Okay, if I want to find the sum of those two vectors, the sum of those two vectors is called the resultant vector. Okay, if you think about it, how fast would you be going in comparison to the other people who are walking? You would be going 8 meters per second. Okay, in other words, the sum of those two things, okay? 8 meters per second might be a little bit fast, actually. But anyway, we're just kind of using numbers here to represent what's happening. All right, well, let's switch this around a little bit. So let's go back to the original. Let's say that the walkway was moving at 3 meters per second, all right? But you want to walk the opposite direction, and you want to go at 5 meters per second in the opposite direction. Okay, so we could think of this maybe as being a positive 3 meters per second. We could think of that maybe as being a negative 5 meters per second. And if you want to figure out how fast you'd end up going, you're going faster in that direction than the walkway is going in the opposite direction. Okay, so if we add a negative 5 meters per second and a 3 meters per second together, you end up getting negative 2 meters per second to the left. Okay, and we could say that's your resultant velocity. Okay, so my point here is we can say, oh, the walkway moves at 3 meters per second and you're moving at 5 meters per second. Those speeds don't tell us anything about the direction. But if we're looking at vectors, the directions matter. Are you going the same way as the walkway? Are you going a different direction as the walkway? Okay, but vectors allow us to take this even further. All right, we can work with problems where maybe things are not just moving left and right. Maybe they're moving at an angle, okay? So we'll look at problems, for example, where we have maybe like a river, and the river maybe is flowing to the right at 3 miles per hour, and maybe you're trying to cross the river, okay? Maybe you're trying to go this way at 2 miles per hour, okay? And the river is simultaneously kind of carrying you to the side. How is that going to affect your motion, okay? So if the river goes this way, and you're maybe trying to go this way, let's say 2 miles per hour to the north, and the river's going 3 miles per hour to the east, okay? And if you think about this, I think most of you would say, well, okay, I think in the end, you would end up kind of moving like this, but I don't know what your overall speed would actually be, or how fast you'd be going, and I don't really know exactly what the final direction would be, you know, maybe 45 degrees, something like that, who knows? Vectors are going to allow us to discuss this type of problem, okay? Vectors are going to allow us to to look at problems where you have different velocities moving in different directions, air currents moving things, water currents moving things. These problems are also going to allow us to look at forces. If I shove something in a certain direction, I'm applying a force in a direction. There's a size of the force. How many pounds of force or how many newtons of force are you applying? But there's also the direction that you're applying that force. And so, you know, a game of tug of war would be very obvious. You know, if 2 of you pull in one direction at a certain force, that's very different than if 2 people pull against each other on a rope in opposite directions. Okay? So vectors are going to allow us to analyze all kinds of problems in the physical world. Sadly, in this school year, we're not going to be able to go too far into that. But we'll certainly learn some basic things, and you're going to see a lot of connections to things that we've learned previously, okay? So getting a little taste of this as we go into the end of the school year, but hopefully leaving you kind of looking forward to some of these topics when they come up again in future math classes, okay? So got a couple more videos. I'll see you there.